40 months of cooperation between AABN members, entrepreneurial communities, professionals from various fields to leverage AABN as critical driver of development. Since the launch of 27th June 2020, the forum has garnered a lot of interest and excitement from all regions of the world. The forum has had the best balance of participation, both in terms of members, regions, and gender. From the beginning, our goal has remained the same: to help entrepreneur community to replicate examples of good and sustainable use of AABN, and to encourage everyone to make good and timely use of the rich database available. As we move forward with strategic plans to ensure AABN's future, we will continue to invest in the vast potential inherent in collaboration among individuals of varying backgrounds, perspectives, and experiences. Climate change is inevitably one of the most perilous man-made challenges of the 21st century. As global temperatures soar and weather patterns become more erratic, there is hardly any facet of the life that has been left untouched. Combat climate change, countries across the world are exploring various forms of renewable energy, such as wind and solar energy. Green hydrogen and blue hydrogen made from natural gas through carbon capture, utilization, and storage are the latest in the global fight against climate change. Green hydrogen particularly is put as the cleanest form of energy, as it has zero carbon emissions. In the recent past, green hydrogen has emerged as an attractive and viable technology that has received tremendous support both from the government and the industry. It is turning out to be a key component of India's ambitious renewable energy plan. Reckoned as the most abundant element in natural gas, has multifarious applications. Taking cognizance of the versatility of hydrogen, India aspires to become the global leader in the production and export of hydrogen over the next few years. Hence, the government has started taking requisite policy measures to facilitate its easier adoption. In this webinar today, our eminent guest speaker, Mr. K. Ravindranath, former Senior Vice President and whole-time Director of L&T Hydrocarbon Engineering, will touch upon the cost competitiveness of green hydrogen and how it can be a game changer for India. Through this webinar, he will also discuss how the industry is responding to green hydrogen, the challenges in employing latest technology, and whether some of these challenges can be addressed by interventions from various stakeholders. I have the pleasant duty to introduce and welcome our distinguished guest speaker, Mr. K. Ravindranath, at Green Energy, Indian Scenario, an interactive business networking session. K. Ravindranath is a chemical engineer from IIT Kharagpur with masters in chemical plant design from IIT Madras. Had a long career with L&T for over 4 decades in various positions, starting as a postgraduate engineering trainee, as a cluster head of multiple business units and several turnkey EPC projects, both in India as well as Middle East, for the process industry in the areas of refinery, fertilizer, gas processing, petrochemical, and associated chemical plants. Before his retirement from L&T, he was Senior Vice President and whole-time Director of L&T Hydrocarbon Engineering, leading onshore and offshore business comprising of several strategic business units and engineering centers. He was also Director of various L&T joint venture companies related to hydrocarbon business, including L&T Chiyoda, L&T Gulf, and others. With his diverse background, I'm sure today's gathering feels special because of his participation. And dear friends and entrepreneurs, I hope you enjoy the program and find it useful. Have a nice time. Thank you. Over to you, Mr. Ravindranath.
Okay, thank you very much, Mr. Gopi, and good morning to all once again. And it's a pleasure to be with this group. It's a large group. I heard from Gopi that you are over 700 members in this AABN. And that's I told him this is one of the largest which I ever heard of. I mean, other groups are, having a WhatsApp and then trying to connecting up with so large number of people is a great. Just at the outset, I want to tell you that I'm not an expert on the technical part of any of the things which I'm going to tell you. In fact, my chemical engineering bent of mind and technology orientation in L&T all through, irrespective of the position which I have taken, I continue to be focusing on technology in L&T also in various businesses which we were undertaking. And just before my retirement, I initiated this green energy program in a very minor, very small way. And then now it has grown into very big, which I will let you know as we are progressing. And this is one of the disclaimer. I'm not an expert, so a lot of people who are in this group may be very active and in this line, and you also may be quite active in what I am saying, and you could step in and correct me if at all there's any uh, wrong understanding of on my part. Number two, of course, is I picked up a few slides from my L&T colleagues also. My general manager, Mr. Balram Krishna, he's given me a few slides just to give authenticate in what I'm saying in terms of some process plants, which where L&T is also trying to do and others are doing. So with these two in mind, I will just start this presentation. I'll just share the screen. Can you just see this, please, all of you?
Yes, sir.
Yeah, okay. Yeah, my focus on this day is essentially on the green energy, what's going on in India. I believe, I think India is quite in the forefront as far as the green energy initiatives are concerned. And, and then I would say that we could be one of the leaders going forward. With that in mind, and I see a lot of interest is coming in, but then there are many challenges which normally, I mean, we would not find it difficult in India to overcome. That's one of my hope and trust that we will definitely do much better than other countries, because we have a lot of abundant energy available, especially the solar side, which is the key starting point for any green energy initiative. Without that, I think other energy scenarios which we'll see, they're there, but then they won't be contributing as much as probably solar and wind. Just going forward, this particular slide is a bit packed slide. I hope you are able to see this, right? It's clear. So one is, I just want to know, Gopi, is okay?
Yes, sir. It is clear.
Okay. Now, if you're having any problem, please do let me know, because I won't be able to get to see that whether it's really been communicated the other side well or not. Any one of you can interfere and then stop me halfway through. And so to start with the decarbonization, which is being talked about in India, most of you may be aware of this, but just a recap. There are Panchamrit promises made, 5 of them, in COP26 held in Glasgow. Now there was COP27. I mean, this is one of the very significant committee of parties in 26 that's happened in Glasgow 2 years back, and where there's some bold decisions have been taken, and India also committed a few things which they would do. Subsequent ones are, I mean, there's one more that has happened in Egypt, and one more is going to happen in Dubai now, sometime this year or 2024. I think 2024 is going to happen. And that's obviously is the one, they didn't get much excitement in the last COP, except some kind of funding that is announced. And then again, there are complaints that this funding, what is announced, is not coming through. So there are 5 net zero of emission by 2070. Though we said very firmly, and people felt it is too late we should do much earlier than that. But then subsequently, I think a couple of them, like China said 2060, and I don't know, one has to see that. But even to meet this 2070 target, what we need is multiple aggressive strategies are required. Just on one strategy is not going to happen, which I will just little bit get into the details subsequently. Renewable energy is a capacity we promised that 500 gigawatts we'll do by 2030. We are currently about 180, and about 88 gigawatts is under construction. So that makes it 260. So we still need another 250 in the next 10 years, or less than 10 years, or 8 years. So we need about 40 to 45 gigawatts of renewable capacity that need to build up every year, which is a big challenge, I would say. And we have to obviously forcibly move forward in this direction. Third one is the carbon intensity. Carbon intensity, if you say, just see the tons of carbon dioxide per annum that a country emits per unit GDP on a purchasing power parity basis. I think this is a bit of a misnomer. There is about, we said 45% we will reduce compared to the 2005 level of carbon emissions. And I think India has done quite well. If you see on the right side, bottom part of my slide, you see the one which I colored it with a red color, if you say, process efficiency improvement, increasing share of renewables like solar, wind, and partly hydro, ethanol blending, which is going from 10 to 20%, fuel switching from coal to gas-based industry, even cement and steel, they're started looking at gas quite a lot. So obviously the CO2 emissions in the gas is lower than coal. So these kind of things, plus GDP by itself is on the higher side. On a PPP basis, today 3.5 to $3.67 trillion would be equivalent of $8 to $9 trillion on a PPP basis, by which I think we already achieved about 35% in 2022 itself. So, but more than that, I think one has to also talk about carbon emission, reducing by 1 billion tons of carbon emission by 2030. That's going to be a big challenge by itself. Today, if you see on the again right side of the slide, the energy mix which we have got and the CO2 emissions by sector, if you see, energy mix is something like what we are slightly, this number is a little old, maybe 2021 ka number. But you can even think that 38 exajoules. Exajoules is something 10 to the power of 18 joules. So coal predominantly at 44%, oil 24%, gas about 6%. Then renewable is only 11, and nuclear is a very tiny living thing there. So what it makes is that coal has to reduce, obviously, and oil has to reduce. Would be quite difficult situation, as you can see. If something which is coming up to almost 70% coming in these two, reducing is going to be difficult. So obviously abatement is going to be a great sort of initiative that has to take place. We are emitting something like a 2,300 million tons of carbon dioxide. It will be 2.3 billion tons of carbon dioxide. If you are adding the greenhouse gases, then it will be another 0.4 billion. That means about 2.7 billion tons of emissions which we are getting into. Of course, it's a very small little thing compared to the emissions which are coming out of 40 billion tons in the whole of worldwide. But India is a big contributor in this area for sure. In terms of installed power, we are maybe around 500, just about under 500 gigawatts today. Coal predominantly 220 to 30 level. Renewables is about 180, as I mentioned. Natural gas about 25. Within renewables, solar is just about 75. And wind 50, hydro 45, biomass 10. If you just take this kind of a breakup, when are you going to achieve that 40 to 45 gigawatts of energy from the renewables by 2030? That's a big question mark to me. I mean, then one has to really push hard. Few companies are doing that. I will tell you as we go along. And one more thing I want to say, we said non-fossil energy by 50% will reduce by 2030. That needs, as I mentioned to you, this much of solar and wind. So if you see left-hand side bottom part, bottommost part, I said coal is the most reliable source of power generation in India, obviously. And just about, as I talk today, we are about 50 gigawatts of coal plants are still under construction. If you have read about recently, the one point of my presentation here, what you see is a lot of information which I collect from the public domain. I mean, it's all available in the thing for you and for us, all of us to know about it. But maybe my interest is more, and I dwell upon into the little bit of a deeper into that and got in some, culled out some information and put it in these slides. If you just look at that, Power Minister recently said that we are not going to phase out coal, which is what I think we have been forced upon in COP 26 and 27. They wanted India to phase out coal. But I think our present government is pretty strong in terms of communication, in terms of saying what they want to say very firmly. And they said, we are not going to phase out, but we'll phase down. Phasing down is obviously to reducing the thrust on coal and equally putting too much of thrust on the other areas. So they said, okay, we are doing about 50 now under construction, another 30, 40 we will do. Thereafter, we will taper down. I mean, that's what they meant by. But then coal will still be a major contributor to our power generation a lot. So obviously, there's one point I would stress upon is what happens to the CO2 you generate on the coal-based plants. That's the
Sir?
one we need. Yeah.
Local ஆயிடுச்சுங்களா
Sorry.
அந்த சில்ட்ரன் ப்ரோக்ராம் போயிட்டு இருக்கா
I think somebody is. Can you kindly mute on him, please? So I'll continue. So the no more coal-based plant probably after that. The nuclear, whatever you may say, it is not going to contribute in a great deal. I mean, so even if you get about 20 gigawatts out of that, in the great thing 2030. But one thing good that would that's happening, and then it should happen a little more, is actually switching over to natural gas, LNG, from coal. More and more LNG terminals. I think many of them we are coming in. We had a breakthrough long back to get an LNG terminal in India and with Petronas, and then now then it's going more and more into the other areas like then ethanol blending fuel. It will happen, but this is not going to be a major contributor. About 10 to 20% we will do. But then one last point, last slide it is, but not the least, is actually CO2 sink. Having an enhanced forestation, I think this is something which our youngsters can take it forward and then ensure wherever we are, and the forestation is the one which is given a priority. And I just want to, on this slide, before we move on, on the right-hand bottommost, I have put something which you must be very much worried about. In all of us, we should get worried about. Current global warming level is 1 plus 1.15 degrees centigrade. This is actually pre-independence, pre-industrial area time. This 1.5 just gone up. So coming from there to now, the red line is about 1.5, means we are very close to that. We are creeping towards 1.5. But if it is, you don't do anything, then it will go by 2100. Someone says that it will go to 2.8, and that is a catastrophic. This catastrophic will, what it means is there's a huge floods, mainly in Pakistan and China, they are predicting. Severe heat waves, which is going to be in US and Europe, which are not facing so much, but they will. And then the severe drought conditions in African countries. The ice melts at the poles you're going to have. I mean, this is the kind of a thing which warning, I always put this and stress upon this. So this slide, I took some time to say that there's so much of decarbonization effort that is going on in India is all summed up just in this slide. I mean, really, if you see, somebody wants to get into that, any of the entrepreneurs in this group, any of the people who are already into the energy, alternate energy scenarios system they are adopting today, this slide is the one which they should keep it in front of them and then keep working on actually. Now, I just mentioned that 2070 targets one can achieve only when you have multiple strategies. There are 5 major strategies, I would say. And probably you won't be able to give equal weightage to each one of them. So obviously, what I'll just end up saying what one could give. But to start with renewable power, solar, wind, everybody knows, battery storage. See, one thing about solar or wind or any of them, they are all time constrained. I mean, we have about 8 to 10 hours. Wind, of course, we will depend on the velocity of the wind in the direction. So we are still nature dependent severely on this part. And so obviously to have a continuous grid management, you need to have 3 times the solar panels and 2 times the battery storage at least. So battery energy storage system, which we never thought of so seriously in India anytime, is becoming one of the most challenging one. I mean, so the developments on the battery, I will just take it up as we go. This is a very important thing. Not much of a concentration that has, not much of effort has gone in worldwide also. Everybody was using batteries mainly for a very small consumption, for cars, for our cells, and then very, very small current densities and the power connections. But as we go along, we need a huge ones. And then obviously that's the one which is going to be there. Apart from the battery energy storage system, is being talked about as a pumped hydro energy. Again, I have never heard of this so much in India during my whole of career in L&T. And then I started looking at it. Then I said pumped hydro energy is a thing very predominant in Europe and other places. they use the like Istata, and then they have 2 reservoir systems, and then pump it into one reservoir when the sun shines, and then when it is not there, and then get from the reservoir down to the turbines and generate power in the off solar times and so on. So people are using it elsewhere. In India, a couple of projects are there. Obviously, there is not zero in India, but minuscule. And apart from battery energy and pumped hydro energy, these two can be an energy storage systems, as I see it, which is a very essential part of our renewable energy focus. Number two, hydrogen economy. I don't have to say much about this. Too much has been talked about. Every day newspaper, something about hydrogen. Everybody talks the green hydrogen. So this is fine. The hydrogen is good, but I will talk a little bit more on the green hydrogen because it's an interesting subject for many of us. But today, India consumption of hydrogen is about 6 million tons per annum. 50% is in refineries and about 25%, about 2.5 billion tons is used in ammonia production and urea fertilizers, and balance only for the other parts. So if you are asking me, and the third part going into carbon capture, this is the one which we completely not looked at seriously in India for a long, long time. And the worldwide also is the same, except a few countries who are pressed to doing that, they have done it. But I think the reason in India being that it's a very sort of cost ridden system. I mean, if you are looking at, I just take some figures for you. I mean, Middle East started doing the CCU. I mean, what I understand very seriously, carbon capture and then storage, because they have got a huge abandoned deep water fields running into 2 kilometers below the water and so on. And hydrogen, carbon dioxide is hydrostatically stable, so it's very easy to store underwater compared to any other gas. So one thing, but Middle East somehow they achieved a $15 to $20 per ton of carbon dioxide kind of an economy for this kind of a capture. They are doing it quite well. Middle East is doing something very interesting, if I tell you, which some of you in this information you would already know about it. See, what they're doing is they're producing hydrogen or ammonia by a normal route. Normal, what we all do it, I mean, in a thing. And then CO2 that comes out of the CO2 is used for urea, which is not being used, which is the other one that all taken to CCU level, capture, then exporting that ammonia to Japan. And Japan considers this as a green hydrogen, by the way, because CO2 abandonment has taken place. And they don't care how you generate hydrogen, as long as the CO2 coming out of that you have put in underwater and you stored elsewhere. So Japan imposed that as a green hydrogen into their country. 10 to 15% of that they are using in their boilers, ammonia directly, and furnaces. And then this is going to be a great export for Middle East. And Japan also doing to their own extent about carbon capture, but then they have about 800 meters down they have to do. 80 to 100 dollars a ton is their cost. In fact, cost of capture itself is 50% of that, and cost of storage another 50% in most of the countries. I will just tell you as we go on CO2, there's one case of Norway, which we'll talk subsequent slides. I don't want to get stuck on that. Otherwise, CO2 is being used for enhanced oil recovery, and the CO2 used for some chemicals in India. That's not a big thing, but it has to come in a big way, carbon capture. Then biofuels, I don't want to dwell too much on that. You guys know all about it, 1G and 2G and ethanol, and very well-known industry. Only one part I will give one slide subsequently is the gas fermentation, which is a very interesting concept coming in. Last one is the circular economy. I mean, for one, I'm not very sure much is, I mean, almost India is doing nothing, but this is actually a waste plastics to a value, converting unrecyclable. For example, PP, PVC, they're all, we can't recycle. Whereas PET and paraxylene, ethylene glycol, these can be recycled. But then nobody bothers in India so far, but other countries started looking at it. That's how our leaders in energy scenario, most of you who are all here, you know, either it is UOP or Lamas or anyone, they're all getting into a lot of technologies related to this. What they're doing, pyrolysis technology. For example, I noted down one point where UOP developed a catalytic process for converting this. And then Total Energy, Aramco, and SABIC, they are doing a plastic waste derived oil, PDO oil, they call it actually, PDO oil from pyrolysis. That's a technology being given by Lamas technology. So there are a few recycling process taking place. But in summary on this slide, I would say you have to get about 60% from the renewable side, and then about 20% from hydrogen. Hydrogen is not going to give more than 20%, and about 20% carbon capture. These three will be predominant. And if I put carbon capture 15%, then 5% can come into the last two parts. Okay. Now let's talk a little bit on the green hydrogen. A lot of experts on green hydrogen here. I think Mr. Kamath and Gautam, they're all in the business of this hydrogen anyway. So for those, I think, who may not be completely aware of green hydrogen, there are three types of hydrogens. A gray or a black or a brown or whatever you may call, that's one hydrogen, which is done by a normal conventional process, which we are all done. I have done a number of these plants. Gautam was my colleague in L&T, and we have done this. And we have done a number of hydrogen plants. In fact, we made breakthrough, like my BP cell, Mr. Raman, Sriram, they're all there. So we have done a project for them, and mainly we use a helicopter technology for us. And so, and then there's a blue hydrogen is the one which we have. Just 1 minute, please. Sorry. So what I would say is that actually blue hydrogen is something where just I mentioned to you on the Saudi Arabia case, that you take the SMR, remove the hydrogen, and then remove the carbon dioxide and put in the CC, and then that's done as a blue hydrogen. And then green hydrogen is the one which is done by electrolysis. Obviously, you have from water you generate the hydrogen, so by electrolysis of the water. So these three are the three types of hydrogens which you are well aware of. But then, how do we store this? Hydrogen can be stored as a liquid, but at minus 253 degrees centigrade at atmospheric pressure. And hydrogen has got a very, very peculiar situation. Hydrogen molecule behaves something differently. I think some of the experts on this chemistry side can tell me. This molecule, I believe, it doesn't follow the Joule-Thomson effect. Means if you start sort of expanding this after compressing, and then it gets heated up and so getting cooled down up to minus 180 degrees centigrade, and then starts cooling down. But then what would you do up to minus 180 degrees centigrade? It's getting warmed up. So obviously you have to use LNG or something like that to cool down. So it's a very energy ineffective process, I would say, to have a liquid hydrogen. At the same time, it will have some applications, very limited applications, and that much one can lose the energy. There's no problem. Whereas the limited application where it is essential to use liquid hydrogen. Otherwise, predominantly the gaseous hydrogen at 700 bar is the best density. You get about 40 kg per meter cube. So that is the maximum size of a hydrogen tank one can get. But 700 bar has got associated other costs and as well as safety issues. So 350 is what I think, 100 to 350 is what people are talking about as a gaseous hydrogen storage. And the third, and on the extreme left side, extreme left side, when you see is chemical storage. I don't know, many people would have heard about this, when I started looking into that, Japan is looking at this LOHC. LOHC is actually liquid organic hydrogen carrier, they call it. So what you do is hydrogen, you bond to another chemical, which is an unsaturated chemical, saturate that, which gets into a liquid form, transport in the liquid form, and then again dehydrogenate to get that. And then you get the original liquid. So obviously you are not getting the effect of whatever you call the carbon abatement at one place. So you have to do two different places. But then nevertheless, it is a good transporting case. It's a carbon neutral. One side you're lifting, one side you're leaving it out. And at this one, actually, organic liquid carriers are something like a methyl cyclohexanine, hexane, dibenzene, toluene. I believe they can be used to get toluene into a cyclohexane, and then which is a liquid form, transport, and then dehydrogenate, and to get that. There are platinum-based catalysts and other non-precious metal catalysts, molten metal catalysts. They have been using it to get into this kind of a technology. But then it's a technology by itself. It will take some time, and I don't think India, anybody is talking about this so far. So one has to wait and see that. Industrial application, predominantly hydrogen gets into refineries, fertilizers, steel plants now, and power. Mobility is a very limited. They're talking about the fuel cells for high trucks, transportation of the trucks, railway lines, and then various transportation methods one can use. Probably I have. This is a slide I have on the transportation. If you just see this slide, this is what some of these slides I picked up from my colleague from, if you see something very intense technology part, I think I would have picked up from Balram, my general manager in L&T. So I acknowledge his sort of support and then contribution to this presentation. So volume of this hydrogen on the left side, if you see on the y-axis, and x if you see distance. So various options are there depending on the distance which you want to carry this hydrogen. So most of it will be 10 to 1,000 tons per day. To the extent possible, it has to pipeline transport. That's why GAIL is actually doing a lot on that mode. They want to transport this in the same gas lines what they have laid down almost all over India. So they're testing out a few areas. I understand from Mathura to some nearby place. I've noted down somewhere, Mathura to nearby place. They are actually testing out about 50 to 100 kilometers of distance. Let's see how it works, this pipeline transport, and what are the difficulties they may face. Now, if you just see that, compressed hydrogen can go up to 10 kilometers, maybe 100 kilometers, there's no problem. So probably that could be one source. And the cost, if you see the cost, how the figures inside this, what you see, all the cost that gets added up of the transportation. So you can see that today people are talking about getting hydrogen from a $4 to $5 a kg today, getting down to 1 to 2 is what talking about. That's also a few people talk about that. And then now you're adding this transportation cost. So it is going to be uneconomical. So what is the solution? Solution could be something different out of all these transportation ones. If you're going to a larger case, 1,000 to, outside, intercontinental, it has to be that ships. Ship transportation, probably LOHS will, once it becomes a little more mature, I think LOHSC will become a great sort of initiative, which is being done by Japan right now. I think hopefully Halatopso is supporting on that. So we will have some of the technology supplies getting into this, and then that would have a very quick sort of maturity levels in terms of cutting down the costs, in terms of enhancement of technology, improvements in the one, and so on, So I always like if I see some very front-end top-class licensors are getting involved in this kind of a developmental work. That would be an excellent thing for all of us. Yeah, one thing I would like to say, and I said that what is it that other than this transportation of this, what is that one can think of? Actually, one can think of having small hydrogen plants. I mean, that's one solution. I mean, have multiple hydrogen plants. That's why everybody is concentrating. In fact, that will be very much required as I go forward and tell you why is it required. So we'll talk that a little later. This can be done the way I put on this slide for specific cases, including a fuel cell for truck transportation. Fuel cell has got its own lot of advantages. It's a mature market. Fuel cells is not nothing new, but then it's also got a lot of disadvantages. Now, electrolyzer. Why I just taken all these initiatives which we are talking about on the green hydrogen? They are nothing. I mean, they come to zero the moment you have a problem with the right kind of electrolyzer selection and electrolyzer footprint, as long as the size of the plant is concerned. For example, alkaline electrolyzers are very well known. No need to talk about it much. PEM is picking up quite a lot now, and I'm sure that going forward, PEM will get into a big way. PEM is, of course, for those, it is a proton exchange membrane electrolyzer. And this is actually solid polymer electrolyte, precious metal electrodes are used here. And the advantage of PEM over alkaline is well known. I mean, chloralkali industry, many of you would have used it also. Efficiency wise, there's not much difference between the two, 80-82%, and this is 78 to 80%. And operating conditions are little higher in case of PEM, but that won't be a deterrent at all in the industrial level. And the most important thing that gives you the two really advantages you have. Very high current density in case of PEM compared to the alkaline, 0.5 amperes per centimeter space, 3 one can get. Yeah. And secondly, obviously that brings down the footprint of your electrolyzer size. You can get about 1 feet by 40 feet, a 1.5 megawatt electrolyzer, compared to even half of the 1/3 of that also takes about 1 foot by 40 feet. Both are commercialized. The third one, which again, Topsoe is giving a lot of emphasis, and they're developing. Where Topsoe is an innovator. I mean, all of us, most of us, we worked with Topsoe. I worked for 25 years with Topsoe, fellow Topsoe, right from the beginning to get them into India to many things, especially reformer, where my friend Gautam was an expert on that, reformer. And so the SOEC is, of course, a solid oxide electrolyzer cell. This is it's a different thing altogether, but then it's a high temperature, superheated steam is used. I do not know the principle, and principle I know, but I do not know the kind of technology features involved in this, electrodes and so on. It is still under commercialization, so maturity is quite far away from today. I took this slide as a second slide. When you talked about electrolyzer, every one of us will get in your mind, what about electrode materials? Everybody knows only lithium today. I mean, lithium is the one, lithium and so on. But then it has got a limitation on the cost, lithium. I mean, if you just go into a KWH, what I understand, because a friend of mine, a classmate of mine from IIT Kharagpur, he's an expert on batteries and electrolyzer. He's in USA, started his own startup company, developing something of a futuristic electrolyzer and a futuristic battery storage system, which would be something of a very great thing when it comes through. By the time this industry is maturing, I think he would come out. It will take about another 4-5 years for him. So when I was discussing with him in USA recently, and then I found that there's a lot more has to shift away from these minerals like lithium, cobalt, nickel, graphite, copper, and chromium, and so on and so forth. These are the ones which are controlled by very few countries. Most of you know that. I took this, it's come in Times of India long back. I just took this cutting and put it in my slide. I like this slide on the right side, what you see, this one. Just gives an overview of which country is producing how much million tons of these precious metals like nickel, copper, graphite, cobalt, lithium, and so on. And then what is the share of which countries are taking these metals into their countries. You can see this. The lithium maximum in Chile and Australia, and and cobalt, if you say 70% in the Congo. They're all very difficult places, not Australia, Chile, or Congo. They are all difficult places, and then very difficult to get the regulating authorities to give it to India or anyone. And China is holding a lot on the graphite. And China is smart, and they have done way back, and a lot of these things they've imported into their country. They have got a sort of supply contracts with these countries, and they have developed a lot more on the processing and refining. I mean, that's where I give credit to China in like they're doing many other things, and this is another one where they got a lead role today in terms of that. Obviously, we have to overcome that, and India has to also face how to do that. So obviously, the Solution to this is new sort of minerals, metals that need to be used for the work. I would say that lithium is good for electric cars level. I mean, it is good. Beyond that, I think one has to look for a large capacity electrolyzers. So I've just given that IEA, that International Energy Association, they put that in the last 5 years, lithium demand has increased 300 times, 300%, cobalt 70%, and so on. You know? And as I mentioned, these are controlled by very few countries. So global supply chain management is going to be very, very critical for this. And because there are only 3 or less countries, and regulations and policies of sustained supply would have a lot of export restrictions and so on. You know? And India is making efforts, already started negotiating with some of these countries, and but production and refining and so on. In fact, you all heard my last sentence on the left bottommost last line, discovery of about 6 million tons of lithium reserve in Jammu and Kashmir and Rajasthan. So it's just a discovery. I mean, one has to prove that it's really there. Number 2, you have to extract, you have to process, you have to refine. I mean, this will take about, I mean, I would not say anything like this would happen less than 5 years. So electrolyzer. So I just mentioned to the right type of electrolyzer, selecting an electrolyzer, having a collaboration with the right electrolyzer in global level if you are not able to have local. And third, having the right electrode size is the one which I would say are going to be critical factors for green hydrogen. Before I go to battery storage, I would just say that most of you, I mean, a lot of you are, at least majority of you are in South. And one group which I always liked and I worked with way back in my very early days in R&D of L&T, we developed an anodic passivation system for heat exchangers in a sulfuric acid plant, substituting the so-called trombone cast iron coolers, huge ones, replacing them with a stainless steel heat exchanger, but then having an anodic protection. I worked with CECRI Karaikudi. Unfortunately, that's one institute would have gone places, I'm telling you, with the kind of background they have. Except the last 3-4 years when there's a lady, I mean, I'm not remembering her name, when she was the director of that institute. She did a lot of, because she is a technocrat herself and came from the ranks. And she did some good amount of brand building for that. But otherwise, that institute today should be actually leading in the forefront on the electrolyzer batteries and things like that. You know, I would love to see that CECRI growing in Karaikudi to become one of the leader in this electrolyzer thing. Some of you really looking into the electrolyzer, go and meet them and then have a dialogue with what they are doing today. I'm no touch with them. Though once I tried contacting the lady who is very, now she's moved to center as a, I think within a DGCRI or something like that. She moved out recently. Just this is an information for those of you who are interested in this. Battery storage is the second most important thing for even for most of our renewable energy systems, and also no less for hydrogen. There are 3 types of battery storage. One can have something like a short or a medium or a long duration energy storage. But there are only 2 types right now today people call SDES and LDES. Short term duration energy storage is 4 to 5 hours. Means you have a high power, small capacity, and relatively expensive, using either lithium ion or a sodium ion electrodes for that. That's a battery which you can use for the short duration energy storage. Where a long duration storage thing, you need a very high power. Means about they should last for 10 to 100 hours. And they are type 1, that is what I call medium, but they are now calling it LDS type 1, 10 to 100 hours. And then type 2 is a 3 to 5 months. That's a long, really long duration. So that's a low power, very high capacity, whereas and least expensive, and you should take care of the seasonal demand. This, I believe, will come under flow batteries, which I have to understand a little more. These flow batteries, my friend is working on that, and I will get to hear from him a little more on the flow batteries. And otherwise, there's vanadium redox flow batteries done by China quite a lot, and that still gives about 10 to 100 hours, I believe. And sodium ion, and that I would talk as we go forward. I mean, a lot of work is going on in this batteries, and then looking for the right kind of a material for that, And government actually has also seized up the situation, or although they know that people will find it difficult to generate large quantity of renewable energy, but they are not able to store it because the cost of production of renewable energy is equivalent to cost of storage. So that gives a huge, I mean, you will not have economical power at all to deliver to the grid. So obviously, people are looking at what do we do. So government, what they have done as incentive, they are putting up their own battery storage system capacity. They are investing through different modes, which probably I have some slide later to explain what modes they are following to get this. Let's say 4,000 megawatt or 4 gigawatt hour by 2030, when really this market matures and it comes to a level, and the tariffs are affordable, they will give that, and they will rent it out to the people who are generating. So the guy who's generating one need not worry about a capacity or installing a huge battery system and incurring capital costs. He can just pay revenue, I mean rental, and then get on with it. So it's like a power banks, what you see. What you see, power banks, huge power banks, solar and wind power, they will have this battery very nicely done. Storage costs will come down quite as we go along. Somehow a levelized cost of 5.5 rupees to 6.6 rupees a kWh is what I think government is also looking with all these incentives. But then to get into this kind of I think almost you need about 9,400 crores of investment. But again, government said 40% will get through viability gap funding, but that is has to be seen how we're going to get it. Gopi, I just want to stop for a minute here. You guys are able to hear, and then sorry, I'll just finish this part. This is there here itself. Yeah. You're able to see the slides and then hear me out, Gopi?
Yes, sir. Yes, sir. Yes, sir.
Okay. I'm taking a little faster way, so where it is not required to emphasis. So I hope it is okay, my pace.
Yes, sir. Yes, sir.
Okay. Thank you. And continuing on this battery storage, the production-linked incentives is what I mentioned to you. They are doing it to some advanced chemical cell batteries, what they call it, in about each batch of 5 gigawatt hour. I mean, yeah, it's a pretty big one. I mean, 5 gigawatt hours considered by some people, which is very, very high. They're saying it should be started with a 1 gigawatt hour or a 500, megawatt hour, and so on and so forth. So in 2022, Minister of Heavy Industries, they have given a production link support to about 30 gigawatt supplied ACC capacity, and 3 companies have shown interest and bought this. One at 20, one at 10, and 2 of them have taken 5 each. For example, Vola Cell Tech, Vola Cell, I know that one Vola company who are starting with, I think they are starting with a good mobiles, electric mobiles, and they have their own technology division, Vola Cell Tech. They are going to be taking up this, and ACC Energy Storage, Rajesh Export, they are taking another 5 gigawatts. Reliance New Energy, they are taking about 5 gigawatts. Reliance, anything they take, I think they would definitely be implementing it. They won't be talking on the sidelines. Then, as I mentioned, that expected investments of 27,000 crores having battery applications in EVs, maintaining grid stability. See, grid stability is the one which is going to be the major problem. Application EVs and solar rooftops, consumer electronics, they're all, I think they're all happening, and they would continue to happen. But more importantly, maintaining the grid stability, so that especially multiple inputs coming to a grid, which is actually coming to the huge number of millions of customers who don't care where it is coming from. They want a steady electricity in their homes or to their factories and so on and so forth. So what would happen to them? I mean, that grid stability. So obviously, one thing which I believe strongly, grid stability, apart from all the initiatives on the developments in the battery storage system, is actually developing the smart grids. Already there are smart grids operating. L&T used to do that when they were in the, I think L&T is doing today actually as a part of huge construction electrical group, installation group from our Chennai. So that grid stability, smart grid is already nice, but then that's coming into multiple sources of solar energy, small inputs coming in into the grid is going to upset quite a lot. So that will come more by AI, I think. Artificial intelligence is going to really make life easier for, especially for applications like this. This particular one, I just took a slide, an electrolyzer process scheme. Electrolyzer, we think it is a small, little bit of a thing, what you see like a small battery in our cars or something slightly bigger than that. It's a huge, as I mentioned to you, it could be just to generate 1 megawatt, you need about 40 feet by 1 feet. I mean, that's a big one. But then it's got associated things on water treatment. Water treatment for hydrogen process is green hydrogen is the most critical part. So I believe that costs again, though they say electrolyzer stack costs only 80% of the total plant capex, but for some of the PM electrolyzers and others where they need a deoxidation unit and a very high level pure water that is required to be fed into the electrolyzer to get the best efficiency in of hydrogen. So obviously it is a kind of flow sheet what you have. You can see that feed water supply system, then electrolyzer, then you have a separating out oxygen and then hydrogen. So vented oxygen you went out, but hydrogen one has to do that. Somebody said, why went out oxygen? Why not take the benefit of oxygen? I mean, you get about 60 rupees a kg or something you get out of oxygen where industries can use it. That's another good option to have overall plant cost down. And hydrogen coming out of the hydrogen, then gas holders, purification, then dryers, buffer tanks, compressors. This whole thing comprises of the electrolyzer system. So this slide I borrowed from my L&T colleague, and even this I borrowed from him. And to show you authentically a plant which L&T has put up in Hazira, L&T is a technology-driven group. I mean, anything we do, we always look at the first technical part, technology part, R&D, getting to the details. And irrespective of which area we are involved, whether it is a construction, whether it is a reality, of course, it is a baby in the group. I wouldn't take that into this consideration right now. But other than that, defense, I mean, we went defense in a very small way. And then today we are one of the leaders in India in the defense manufacturing. So what I would say is that, like that, when this whole initiative has come about, a pilot plant sort of thing, we said nobody understands the green hydrogen. People are talking. We want to do in a big way. So our leadership, I must say, Mr. S.N. Subramanian, Mr. Subramanian Sarma, current MD of L&T Energy, and this leadership has thought that we should have a plant, which is a very excellent initiative. And they have put a solar panels getting about 99 kilowatt hour at 1.6 megawatt, going up to 1.6. Then a battery energy storage system they have put one alkaline electrolyzer is what being tested in the phase 1. Then phase 2 will test about PM electrolyzer. Capacity may be a small 45 kg per day, like I told you, pilot plant. And then you get hydrogen at so and so, 30 bar hydrogen will be generating. And then stack power, you can see left side, the specifications of this unit. Hydrogen storage tank we have put. So what you can see, oxygen storage we have put, so that oxygen can be used. And both this hydrogen and oxygen we are using in our fabrication shops, just to tell you why we put this. I'll show you the plant, actual plant. This is a flow sheet which you have got this. Water from the overhead coming in to the electrolyzers, and then oxygen dried up, sent to buffer vessels, store the oxygen, and then hydrogen taken out of buffer vessels, and then take it to the... See here you can see in the flow sheet, this hydrogen is going to the furnaces in our heavy fabrication shop and plate fabrication shops, weld preheat, and Linde cutting machine we have, so that is where oxygen is being used. So we are using this. Obviously, the usage of oxygen and hydrogen are required in the plant. And in the meantime, we are testing out the whole thing. So I'll show you the flow of actual plant. This is a plant, what you can see. In our Hazira complex, we have next to our workshop, you can see one of the base of the workshop. And you have a raw water storage. Then you have a utility and feed water pump. You can see this small pilot plant has got this kind of a facility when you are talking about the hydrogen generation. So it's It's a plant by itself, but there are a lot of technological intricacies involved. For example, in the electrolyzer box here, what we can see, and then DM water box, which is there, and then iterative water pump, then feed water storage, you can see the most critical part of this. Then hydrogen storage with its own safety barriers. You can see that we have put explosion-proof barrier around that. And then you have a switchgear room, okay? And then there's a battery energy storage system here. So we are actually complete in all respect what I just talked to you, starting from a water treatment system, an electrolyzer, whatever the electrolyzer standard, well-known alkaline and PEM, and then well-known battery energy storage system, and then switchgear and other things, whatever it is, control room. Control room also we have here. So now, the purpose of this L&T doing, I will just show you another slide as we go along and tell you why we are doing all this in L&T. Now, green hydrogen demand scenario, this is something good that has happened. In our corporate world, each one of us know that we take a target. And what I see in the present government is they take targets and then they follow with the milestones in the targets. There's a review that is being done by the leader, helm of the, in this leader may be prime minister or the minister in charge of that. They could be the leaders. And then you have in our case, we have an MD or a business unit head. We are all following. We took a Laksha targets. We have a target of doing so and so many the crores of turnover, so much of a disk capacities built up, and this kind of a profit I have to make, and so on, you know, and what is the shareholder value I'm giving from this unit. That's our thinking, and the same thinking is going on in this particular, anything that is going on in this government, most of them. Keep the political things aside, look at the developmental thing only I'm talking. When I take that model alone, there is a lot of focus comes in, and associated problems, of course, it's a huge country we will have, no doubt about it. For example, green hydrogen, imagine that this kind of a thing has been done 3 years back, 2 years back. I think the Niti Aayog report of 2019, I don't know, I've just put on the right-hand corner. That's the one. So, this report says, where is the demand going to come for this green hydrogen? Refining, fertilizer, city gas distribution, fertilizer, again, green fertilizer, steel, mobility, and so on. And some exports, balance exports to start with. And this could increase. I mean, more than our usage, we could even do more exports because other countries will gladly take this because they're all not having this kind of a natural resources endowed with. Okay. So if you see that year on year, 23, 24, how much we need and so on. So one has to build this kind of a capacities, just about 0.18 million tons in first year. And then this, I think we already lost out on this. I don't know, there are some plans, but one has to see whether we reach this target. Or club these two and then achieve by 25. And that is possible if somebody wants to really put in. And so on. So, refining capacity today is about 354 million tons. Currently about 250, but we expect by 2030 about 354. So obviously, India's renewable energy will help a lot. Would allow for our own refineries and so on. You know, and secondly, you have IC to EV transition. I mean, gasoline demand will peak. I mean, the current estimation demand for gasoline will peak by 2030. And demand for diesel will peak by 2040. That doesn't mean that it will come down. It will peak and then continue for a longer time. And crude oil will be more used for COTC, convert to petrochemicals. And so about 5 million tons of green hydrogen is to be required to be generated by 2030. This needs about 50 gigawatts of renewable power. So associated batteries, electrolyzer, and so on and so forth. So one has to go backward, build the whole infrastructure to achieve this part. But there is a focus, there is a target. And this target, how they are getting achieved? So a lot of companies, including especially PSUs, have to take the lead, obviously, and like BPCL, HPCL, IOC, and so on. I mean, they have to take the lead. and they are taking the lead. In fact, each one have got, you can see this list I have, from whatever I collected, I've been reading. Each company like all our PSUs, you can see that. GAIL and IOCL, BPCL, MRPL, even HPCL, I didn't put, but it's there, actually, HPCL. They're all different plant locations they have also identified. Bijapur, Panipat, Bina, then Mangalore, Manali, and Vadodara, and so on. No? So capacities, if you can see, minuscule capacity, small ones. Obviously, this is what makes green hydrogen. This I like this because you have a green energy generator, a green hydrogen generator in your own complex or nearby, used to nearby industries through pipeline transportation. That makes it very, very economical and multiple units. If I want to take one small clue from China, Gautam, you would know for sure on this. You know, way back in when we were doing fertilizer, the whole world is moving into most economical capacity and go above 1,000 tons per day ammonia and 2,200 urea and so on. You know, now 2,200 tons per day ammonia, 4,500 tons urea and so on. But China, very surprising in those days, when everybody is talking about large capacity, they were putting 350 tons per day, 450 tons per day. But China is a huge country, obviously, with a huge population. So they are putting multiple units in multiple locations, you know, of producing that and using it as a localized kind of environment and selling the fertilizer or ammonia nearby. You know? So that kind of a thing has to happen in India now, to my limited knowledge, for sure on the green hydrogen. I think all the initiatives that are going on, like a pilot plant we are talking, the slightly pilot plant, a few people will go for a large capacity plant, like 1,000 tons per day, 1 million tons per annum and all that. But there's going to be very few. Most of the people will go this kind of a thing. A lot of entrepreneurs who are not existing today, they will all come up into this business and they will put up a plant and they will thrive quite well. I could assure you that. Provided, because this is more economical when you do that, because you don't put huge storage of batteries, huge electrolyzer capacity, and so on and so forth. Green ammonia. So this is a bit of a thing. When somebody talks about green ammonia, I have a different takes on this, but anyway, I'll present what is being done by the industry today. A lot of people are actually not ending with green hydrogen. Everybody is talking about green ammonia. I want to produce green ammonia, but there are a few challenges they will face here for sure. Green hydrogen and use it for the application is a straightforward thing, like what L&T is already doing. L&T is generating the green hydrogen and use it in their workshops. I mean, that's just, and I told you the capacity, very small, kg per day kind of a capacity. So that is a limitation which we have to use to fire in our boilers there. We don't want to mix. In fact, we are mixing with NG about 10 to 15% in Hazira complex hydrogen. Maybe we'll increase a little more. What I understand is that one can increase green hydrogen burning up to 50%. That one has to do that. Just a minute, please. I'll just have a walk. Gopi, as I see that we are just about an hour since we started the my presentation. Okay.
Yes,
yeah.
Go on, sir. Go on.
Just to take stock. I just saw that it's yeah, we started just around 11:42, 10:42. Now it's 11:40. Yeah, good. So I'll just try to finish in the next 15 minutes as we all planned by 12 o'clock, and we have question and answers. One is this is the kind of a thing which you all know anyway. Green ammonia flow sheet is nothing new. Feed water conditioning, electrolysis stack, hydrogen separation, deoxidizer is essential in this case. Remove whatever the traces of oxygen that are there in hydrogen after electrolysis. Then cool the hydrogen, compress, store. Now you have to have a nitrogen. Obviously, nitrogen comes in two ways: either a liquid nitrogen through air separation or an adsorption for small capacity plant. Of course, one can use molecular sieve adsorbers for our small capacity ammonia plants. Mixing stations, syngas, there is no difference. Ammonia synthesis, purification, refrigeration, these are all just the same. Okay, and only the electrolyzer plant load factor, I think that determines the compressed hydrogen storage requirements. One can sort of balance out between the stack capacity versus the storage of hydrogen. But you need a continuous storage for ammonia. Obviously, the storage is not an option, but it is a necessity. And one has to maintain a critical rate, so that everybody knows that. And nitrogen generation using absorption technology is for lower capacity. Oxygen content in nitrogen and hydrogen are very critical for ammonia catalyst. All of us know about it, so that's one which you need to do that. So another deoxidizer may definitely be required in line for the safety point of view. If you can see, I put a small table. I think I taken this slide again from Mr. Balram. If you see a flow sheet like this and things like that, I would have taken from my L&T colleague. Okay, just to tell you once again, I have built up all the material part, written part, and electrolyzer capacity, as you can see, 42,000 megawatt. How much of hydrogen can be produced? How much of ASU capacity required? So to produce let's say a decent 600 tons per day ammonia, you need a 500 megawatt electrolyzer. It's pretty huge. Then 107 tons per day of hydrogen. Okay, and a nitrogen capacity of 500. So these are kind of figures are well known, so one can work out on that. Then this is what I mentioned to you about Japan. Just see this. Japan is using an air separation. No, Japan, I mentioned to you, they're importing hydrogen from Middle East and then doing that. So they're if you are getting either two ways, I mean that is but if you are that is on if you are doing on the CCU, capturing and doing it. Otherwise, air separation, water, and then hydrogen generation, then flow sheet of the syngas compression and also the ammonia generation, then ship it and then take it to the furnaces and burn. So people are burning about 10 to 15% in the one. This is what they are doing. But the efficiency is lost out, obviously. Obviously, there's a lot of energy consumption within these units. What you start at a 183 megawatt from the solar energy, and that actually ultimately when it goes to the product burning out here and then doing it is about 120 megawatts. That's the kind of thing which happens. These actually what is been presented here is ammonia, and then you crack ammonia to get hydrogen. By the way, this is the one additional unit. In case you don't want to use ammonia in the boilers, whatever imported ammonia or imported hydrogen directly, no problem. But imported ammonia, if you are taking through a cracking one, and then get ammonia out, I mean hydrogen out. So you are adding another sort of energy unit out there. So ammonia as a hydrogen carrier has got limitations. If you are getting as hydrogen out, you are actually getting only 65% efficiency. If you're burning in the furnaces, it's fine. I mean, then you get up to, you save another 10%, maybe about 75%. Yeah. Some of the green ammonia projects also announced of a large scale I have picked up here. Some people are even talking about much smaller scale, but how viable that, what kind of a reactor they will put for ammonia, that will be very difficult to think about it. For me, 300 tons per day, something like that. Good old RCF plant, we had 350 tons per day, so one could have, that is a lower capacity I think of. But some groups like JSW, there's one Wellspun Energy, earlier Wellspun, now today Avada. And ACME is one of our L&T colleagues once called me one day to tell that they are doing very seriously on this plant, green ammonia plant. The others have announced, NTPC has announced, GAIL, IOCL, they all announced. Coal India say that they want to get into green ammonia. Probably government, if there are others are not stepping in, they will push Coal India, they will push GAIL, they will push IOCL positively to put these projects to achieve the targets for sure, to incentivize, to push the industry, like they have done in some cases in the past, in the last few years, you have noticed that. They push government guys and then they say that now private also picks up once they see the success story of the PSUs on that. Now, I'll dwell upon this, will be interesting to some of you in the next two slides. Really, my take on this, if at all this green energy or a thing are going to happen, this Reliance is one group which I really rely upon, saying that these guys will do something. And sometime back, Mr. Gopi mentioned to me that Dr. Partha Maitra has addressed your group, AABN. Most of you would have attended his program. He's one of the leaders in this area, and he knows a lot about this industry. And if you have heard him, actually, there's nothing much to hear from me on this particular slide, at least.
He was there briefly, sir.
Mr.
Partha joined in briefly at the start of the program.
He's there today?
Yeah, he said he has got some other assignment because of which he had to leave.
Okay. Is he there, Partha?
No, he was not. He was there at the start.
He's my good friend. I'll talk to him in the afternoon. Yeah. He is my good friend. In fact, I want to acknowledge him also because he's given me a lot of insight which I won't be able to share anyway in this group. And also, me and my colleague in USA, because he's interested in knowing what is new development. We had a lot of VCs, video conferences with three of us. And he's a great sort of, what do you call, soundboard. I mean, one can just talk to him and say, I'm doing this, is it good or bad, you know. That's the kind of a guy he's on this area. And so it's learn from each other is the one which we are doing in our, this part of our career, in you say, post-career rather. And so Reliance, why I have got a lot of thing is that this is the one which he presented, I believe, and he also told me, he presented to all of you. And this is the one which is come in the market. I mean, it is well known. It is there all in newspapers items, which I picked up. There's nothing secret about these 4 gigafactories which they are putting up. For example, they are the one who are actually integrated. They are going from gigafactory 1 to 4. Everything they are doing. I mean, there's nothing they are leaving out. Solar panel, they're focusing on best of the solar panel. Even a 0.5%, 1% efficiency by putting the next wave, the coating what they do, or a perovskite film which they do on the solar wafer. I asked him, how much you get out of this? Why are you really putting all this and investing? He says, we get 0.5%. He said 0.5% more efficiency from solar coming out is like a big boon, I believe, which we think it is very small, but it's a great thing. So look at the way they look at the technology. They may have a small group of technology group in their own setup, but then they really network and then get the right experts and then put on board. And Gigafactory 2 batteries, you all know that they already got a collaboration with Lithium Works, one of the leaders. Faraday Ion UK for sodium ion batteries, for lithium ion phosphate. Then liquid metal batteries, they are going with the Amber US. You can see the diversity they are looking at a small, medium, higher level batteries. What I've been talking earlier to you guys is exactly reflecting in a company which believes in implementation. You can see that. I have worked with Reliance, as our partner, as our sort of customer in a number of projects, and right from the Jamnagar 1, phase 1 onwards. So we know them, how seriously they go about it. They are difficult people for us also. They didn't give us orders. We used to go, but then you're convinced, get into the one first LNG project for me to get into Reliance with Mr. B.N. Narayan. He won't give. I mean, it's not so easy, but then he really makes you think and get into the detailing and then get the right price, get the right technology and things like that. So I really am very happy with them, the way they are going about it. Electrolyzer, you can see that. They got a good collaboration with Danish. And then they want to do, because solar, what happens is, just by giving a plant and then saying, oh, I have done my thing done with, it won't work. It has to be maintained. So you need an EPC group, which is set up the plant, take a maintenance work as well, okay, repair R&M, whatever it is, and so on. So they even got that with the Sterling and Wilson 40% stake. They've taken and got that. And then they're putting a PEM for fuel cells they're putting. While other things, they look at electrolyzers. They're also looking at PEM fuel cells, again with Denmark. All electrolyzer and is with a Danish company. They are putting a fully integrated energy storage up to the extent of they have even put a target of 100 gigawatts, and 20 gigawatt they will consume for the whole of refinery, petrochemicals and all that, and have left 80 for the market. So 80 gigawatts out of what I mentioned to you, 500 gigawatts will come just from this group by 2030. If everybody joins up and gives a little bit, I think we can achieve the target of that. Second group, which I believe they are also very good implementers of things, but then they announced it quite well, but that is Adani Group. They have backtracked for the last few years, not the recent ones, but even last 2-3 years back, they announced and then back. But now I understand again they have taken a lot of serious things. So Total Energy is come back and taking 25% interest. So again, I expect that this group, if they are moving, they also go a little bit mega level. I mean, total investment of $5 billion, they want to go in green hydrogen, and they're forecasting $20 billion. They talk big numbers, but then I want to keep, and they also want to have complete green hydrogen ecosystem. I mentioned here, manufacturing of ingots, cells, modules, wind turbines, electrolyzers, everything they want to do that. But all this needs a lot of thought process and then meticulous implementation. I hope they would do that by 2024. They say, even if they do by 2025, that's a great thing for the country. L&T, I have a lot of, I am being L&T and I know closely follow with them. We don't do anything which is just for the sake of doing. I mean, so they are talking about all ends value chain within their limits, what is good for them. Like it's a subsidiary of L&T Energy Green Tech under L&T Energy. And they have green hydrogen production, manufacturing critical components like electrolyzers and advanced cell batteries and EPC projects. EPC projects, I mean, we are there for ages. I mean, I don't think we are need to worry about it. And green hydrogen production, initially the technology part, what we are doing in Hazira is actually to collect every minute technical details of that plant, how it is behaving. And we can do a lot of parametric ups and downs and then get tremendous amount of data. And then we are putting with the deep analytics and then trying to call out the various sort of trends in this green hydrogen. So it is actually, by the way, it is a technology development of green hydrogen that is taking place, which we were not experts earlier. Now we are becoming experts in Hazira. Manufacturing of anything in L&T complex is, I mean, it's just for us, it is like our back of our hand. Electrolyzer and cells or batteries or small little things, I would say. And definitely the manufacturing is a must, and then they have already done. Like Reliance, L&T tied up with McPhree Engineers France for pressurized alkaline electrolyzer. They have got slightly higher capacity than normal electrolyzers, alkaline electrolyzers, including future upgrades. And I'm sure I talked to the very senior level, and they want to, I told them that you have to look for PM as well. PM, I think they would not leave it out. And then I told, given further talk to higher top side, we have to see the SOE etc. part. And and knowing very well that manufacturing of a bigger complex of hydrogen usage is very important. Whatever you generate, green hydrogen or a green ammonia, you have to go down the level. Consumption centers are very important. So we tied up with IOC, and they will take all the hydrogen in their refineries. We'll set up in their thing. So we will set up the manufacturing facilities of the components, everything in Hazira. A plant level, we have got IOC and Renew Power. Renew Power is another very front-end group in the solar energy today, and they are very, very forward company on terms of solar. And Mr. Sinha is doing a great job. So we're going to put a plant on a build or and operate basis. This is one of the model which L&T has moved away from. Normally, we don't invest in the operating plants, but here it's a very essential part. I mean, that's where I liked our leadership and our management, where it is essential we get in. If you have to get out at the right time, we may get out. But today, at least, for this market to mature, you have to produce. You have to show the people that we can deliver. And there is a plan of $3 to $4 billion by investment in 3 to 5 years. By various means of funding and all will take place. And we also have a floating green ammonia project, industrial scale applications with a company called H2 Carrier in Norway, which will also be a good thing for exports and so on and so forth. And just to top it up all, L&T don't want to sit on this and think that we have an internal brains who can work on all this. So they have got about 4 global leaders. Some of them are professors. Maybe some of them have got a background information working on this for over the years. And they put a L&T Green Energy Council. And this is a very unique thing which not anybody has done in India is the one. And we want to achieve the overall carbon neutrality, not just only green hydrogen or green ammonia. Overall carbon neutrality, how do you achieve for this country and for India through L&T? How can you do by 2040? Some of them are very senior, and this is a great move by L&T. So this is another group which I have got a lot of faith that would do something great in ends. Fourth group I have is a Greenco Hyderabad, and this is a group which is coming from some NRIs, and I believe there have been a lot of upfront talk on this. They are put in AM Green, but their model, their strategy seems to be good, and the tie-ups are good. They're tied up with John Cockrell, which is a Belgium company, which is one of the leaders in electrolyzers, 7 to 8 megawatt, and they are also rightly spreading the plants. 1 million tons of green hydrogen they want to produce, probably it will come 4 to 5 centers. They are putting in Andhra Pradesh, Kakinada, some Madhya Pradesh, Rajasthan, and Maharashtra. They're distributing there, and they're also looking for, apart from the battery storage, they are looking for some pumped storage facility as well, and for the round the clock, depending on the location where the plants are coming in. And they are also estimated their cost with their own internal model. They found it to be about $3 a kg is what they will bring out hydrogen first time. That's a good starting point, I would say. Great starting point, I would say. And they are also talking about $1 billion. So having said this, I put these 4 companies which I have kept here. They're talking a mega scale. I mean, when they do something, it would definitely happen. And they seem to be having a good strategy. They're moving in the right direction. Of course, leader of these 4, I would say, the Reliance for sure. And when they come into the market, you're not hearing anything about Reliance now. They announced 2-3 years back, but you'll see every year they will come out with something in the next 2-3 years. And when they come by 2025-26, I think the 2030 target, they will, to my knowledge, they will achieve by 2028. That's a normal trend in Reliance. This NHPC is talking about pumped hydro storage in a very big way. They want to do in Odisha, Maharashtra, MP, and AP. They are following 2 reservoir system. I'll be very happy to see this because this is the one model one can take a lot of knowledge from Europe countries. And they're making it DPR. DPR itself, they won't take 2-3 years. I believe it is a bit of a long period, but if they enhance, then it's a great initiative. Now, being a time limited, I don't want to take too much, and we will go a little faster on the rest of the things because I covered up almost 80% of the what is really required in the country. Rest of them are very quick. Carbon capture, I mentioned, flue gases coming from the power plant is about 12 to 14% carbon dioxide. So that comes out. If it is coming from natural gas and synthesis gas, it's only about 7 to 8%. So switch over from coal to natural gas, switching over is really gives you that benefit of a 12% carbon dioxide versus 7% carbon dioxide emission. So your some amount of abatement is taking place there for sure. Okay. Second thing that one can do is, as I mentioned, CCUS, storage and utilization. Utilization part is only to make some chemicals, which I will tell you about. A couple of them are there, but that's again going to be minuscule. I don't expect too much of that, but a lot of it will come in storage. Even India has to look into that. Here is where ONGC is planning to capture about 1.5 million tons of carbon dioxide annually in collaboration with Equinor Norway. Now, very interesting thing about Equinor Norway, I was very happy to, when I read this news about ONGC doing it, I'll just tell you, ONGC, Equinor Norway right now, they're putting up a plant in Norway. It's a location, I think, about Norwegian government is putting about 73% in that. And then Shell, Equinor, and Total, these 3 companies are putting 27% each. And it's a $1.5 billion project. They are doing 1.5 million tons of exactly same quantity of CO2. They're collecting from various sources of Europe, not just necessarily only from Norway. Norway won't generate probably that much annually. And then putting about 2,600 meters below the sea water. And this project is underway. I mean, it is not a myth. So what I would say that the ONGC is tying up with a company like that. I think probably in future they can even guide us how to do in a smaller abandoned wells, what we have in the deep water Krishna Godavari or a Bombay High and so on. That could be one good thing. Second thing, I've not talked anything about the wind, but the wind energy, one I don't want to miss for telling you guys. I think L&T is working very closely on that. Is actually offshore wind energy. Offshore is where the wind energy is maximum pickup one can do from the wind energy 24 by 24 in all 24 hours. So I would say that is not even much in India, very low, very limited, but I think that has to enhance the work. Ultimately, the new energy transition, I'll say blue and green energy have to coexist for a long time to go, at least our lifetime, I would say. And a lot of youngsters in the group, they will see many other things, and they will see the they should get involved in a very entrepreneurial way in whatever you can do. CO2, when you put it to hydrogen, getting methanol and other chemical is already is well known. I mean, for example, flue gas carbon to methanol plant, NTPC is putting, I mean, a pilot plant to check out on that, how they can do through a catalytic process here. So one has to see the a 10 TPD demonstration plant they are putting up. So this is one option of converting to chemicals. Biofuels, I mentioned, I will only take 1 minute only. These are 3G ethanol, this is a third generation ethanol. Off gas from a refinery, which is IOCL has put up a plant, which is, I would say, it is not a bench scale plant, it's actually a commercial scale plant. Because 33,500 tons per annum of anhydrous ethanol they are producing from there. So that is absolutely about from the PSA unit off gases what they get, they will do the compression, gas cleaning, and then what do you call it? This gas fermentation. Fermentation technology is what they use actually. Gas fermentation using the bioenzymes, So using the bioenzymes, they had a lot of problems with the bioenzymes not performing for a long time. But I understand the technology has come from LanzaTech, and they have done this is what LanzaTech, and then they've overcome all the challenges. This seems to a success. I have to hear from my colleague Balram what is the latest on this project. But it's a good thing. When this happens, I would say a lot of off gases, if they can treat by this and bioethanol, so bioethanol contribution can increase. One can reduce on the green hydrogen, lean a little bit on the blue hydrogen. Why I'm saying all this is for a long time to come, you have a very strange thing on electrolyzers, or you can say batteries and everywhere. I mean, the materials and investments and installations and so on. So the best thing to have a workable solution in the next 10 to 15 years, and then till the market matures to some levels. This is a sustainable aviation fuel thing. Again, my friend has given me this slide to show me that this could be another sustainable aviation fuel. In fact, I was just recently traveling abroad. I saw in Europe the tank, storage tank. If some of you are traveling, you can also have a look at it. SAF storage, actually. SAF, they have written on the storage tank what you see in the airports. So very interestingly, already people are very big way they are going in SAF in Europe. And then a number of processors available. I put all the technology suppliers on the down there. So many processors available for this. LanzaTech, one of the leaders in that. And then you have various processes. Of course, these are a bit capex intensive projects, and more like a fermentation route will be better. Pyrolysis, gasification, thermocatalysis, they are energy intensive as well as capex intensive. Whereas gasification, fermentation, a small way, the way I mentioned to you, and blending this and to a normal fuels would be another abatement. There are 2 slides only. With this, I'm ending. One is there's a National Green Hydrogen Mission. See, what I mentioned about the government sometime back, once again, I'm putting it here. They have got a NGH mission. I mean, this is they put some targets here, which is what I have already explained to you in the previous slides. It's a summary slide, I would say. And unless you have a targets, the targets what you see are only so much of annual hydrogen production, green hydrogen, so much of electrolytic capacity we need, 50 million tons of emissions we have to avert, And that will call for this kind of a, what are the import savings will come. And then renewable energy, how much you would add, and so on. But when it comes to the additional target they have taken over and above this, is a battery energy storage with the capacity they will put it, government. Reuse and recycle of 100 million tons of PET bottles per year on the circular economy, which I told you through the process of Lamas technology or whoever it is. All these they have taken, but we need a lot of funding, a lot of private investments coming in. Even PSUs, government, they have to give some amount of focus and forward thinking on this actually. So I have put about 4, as I heard from people, as collected, or myself, whatever I felt. If you want to implement all this, you need these 4. Somehow process enhancing efficiency within your own systems, cost effectiveness, achieving some kind of a scale in what you're doing it, and safety. I mean, green hydrogen, kind of a thing one has to handle. For example, let me tell you, only refineries, fertilizer plants, they are comfortable with natural gas. If you take the steel industry, they were not for a long time comfortable with natural gas. So today they are using natural gas and then becoming little comfortable to use NG. So let them sort of cross over that fear of NG. Then they will be having less fear about hydrogen. I mean, hydrogen is much more, is a lighter, and it's very difficult to handle, and then safety point of view. But at the same time, we moved from, we never had city gas distribution a few decades ago. But we have today, and people don't get scared the NG pipelines running through your flat, you know. So, but also integrated storage, transport, grid infrastructure would be essential. And I would always give an emphasis, like I said about CECRI, if they don't do much about this new development on the electrolyzers and batteries, I would be highly disappointed in this country. I mean, that's what I want to talk to one of the days, Director CECRI, and then really see whether he's got some plan for that and what is he doing. And R&D innovation to enhance, that's what I mentioned. Innovation is very essential for any group of companies. Most of the entrepreneurs in this group, you please put a small innovation group for yourself. I mean, in whatever business you are in, to go to the next levels. We have done that in L&T. We have been the most successful group today. I mean, we never look back for the last 40 years in L&T. I mean, what we have been doing and going place to place, and then enhancing the shareholder value, enhancing the brand value of India, and so on. You know, I mean, you can do many things on that. And lastly, role of MSMEs. Maybe a lot of MSME startups, they are here in this group, or with the 700 people of yours, hoping you can connect up and tell them innovative solutions are very very essential for any business we do. Last slide, what are the challenges? I mean, just a summing up, I told challenges as I went through the whole presentation, as you heard me, but I summed up here. One, I told you, getting about 500 gigawatts of RE by 2030, $70 billion. Where are we going to get that kind of money? And people are expecting 60% of this will come from private sector. What kind of financing options they have? Question mark. Extensive, I am underlining the extensive manufacturing facilities, electrolyzers, batteries, polysilicon for the solar panels and so on, very essential. And then grid balancing is going to add on additional costs. And then your global supply chain is right now is an extreme optimism on that, but I don't know how that is going to work. And technological safety regulatory barriers, these are one which I think our country and our innovative brain, they will get over with it. In fact, I have had to go through the details of this hydrogen transportation regulation, hydrogen cylinder things, and also the safety precautions. Already there is a highest standard available right now. I think one can go through that. Then tax revenues will come down because diesel and gasoline are substituted to the extent of 2 lakh crores. But then it will be substituted by different means. But some countries in Europe and US also heard about a carbon tax being levied now on certain industries, certain cases. Which is about $150, $100 is the one coming in. Then job losses would be there, and environmental issues is very critical. That is the water cycle, soil quantity, dumping of wind blades, and so on. The local community deprived of water due to runoff, no rivers. That's another one. So I end my presentation here, and then I don't think. I mean, you are all experts, so you can. Any questions, if I am able to answer, anyone else can answer also, I'll be very happy.
Thank you very much for the outstanding session, sir. We'll
Okay.
keep the floor open. Yes, sir. We'll keep the floor open for question and answers now. Participants, you may please unmute and ask questions, please.
Good afternoon, Mr. Ravindranath.
Hi, good afternoon.
Very excellent presentation, and I would say compilation of so many things very nicely done within some 75 minutes or so. Too good a job.
Thank you, thank you.
And let me ask two silly questions.
No, nothing is silly. I mean, in the world, that's what I would say.
I know, but still.
Yeah.
Say, one thing is definitely economically, this is very, very expensive compared to the present energy cost.
Okay.
And when companies like Reliance, Adani, Reliance, these are all willing to invest so much. What is the real motivation for them? When the entire system is not economical, what do they really expect?
No, they don't
in such
think
a
that
huge
it is
investment?
uneconomical. I mean, none of them think it is uneconomical. The guys who are all into the business, who are doing it, they think it is very much economical situation. I mean,
But does not the present cost of capital cost and working cost and all that compared to, let's say, some other equivalent energy, is not hydrogen too expensive at the moment?
that's what I mentioned to you. I mean, the way you go in a small way, now actually one will establish. Nobody is actually venturing into going into the large capacity plants, except
Okay.
I told those 4 announcements only. I mean, they're all announcements. And one has, people will go for the 5 TPD, 10 TPD, 40 TPD, 20 TPD kind of plant, which are like almost like in our kind of, you are a refinery person, so you are all the background of oil and gas. They are
Yes.
all very minuscule capacities when you talk, but then for
Correct.
hydrogen they are pretty big, and one understand the situation, and then get into the bigger scale as you go. See, for example, solar. If you just see, it was what is the cost of solar? It has come down by 85% today. People said solar when it started. I said, how can anybody afford solar in this country? Though you have a huge amount of sun exposure to us. And then today, wind has come down by 65%, wind power, which is a bit top. So I think the industry, once it matured, and companies like Reliance, they have got a muscle power of capital. And then they will go in a very methodical. That's why they're not jumping into the one. They announced this. The mega factories also, they will build step by step, because this doesn't need to build up full mega factory in one stroke. You can start one bay and then have electrolyzers start selling, and then second bay as it is moving on. Even L&T will do that, and that's why they will go with IOC, who will use the hydrogen to start with, and then PSUs. We are not gone with anybody. PSUs normally don't tie up with private parties to have any such arrangements like VOO and all that. This is one of the unique solutions, because they know that L&T can deliver, and they also know that they can use the gas. That is the kind of thing.
Okay. And next is, I am also sure that there is a huge requirement of water, especially purified water.
Absolutely, absolutely. So that is one of the reasons. Sorry, complete your point. Yeah.
No, I was wondering whether that would become a limitation, because already there is a water shortage for different reasons.
I have put that as one of my last challenges.
Concerns, yes.
Sure, that is a good point. No doubt about it. It is going to be the very big big challenge. But what they are saying is, that's why, just to tell you, my colleague, my classmate I mentioned to you, he is doing something which I liked it when I met him. He is a brackish water, because he's not bothered about electrolytes. Electrodes will get developed. He's using electrode, iron electrode about developed, but then brackish water he is using. He wants to use iron electrodes, brackish water, least cost kind of a solutions. If you use direct water without purification into your electrolyzer, that's going to be future, 10 years maybe from now.
Okay.
So again, you take my point there, the innovation, R&D, the people who are already in that work. See, the people who are already in this business are your Karaikudi group in India. I would put all other people behind them. I'm really speaking on electrolyzer and battery. But then
Yeah.
they have not been put even by the government in the front end. But they don't have confidence or a trust in them. These guys will deliver. I mean, they have not shown that. For example, NCL also shown some interest sometime. They have shown up. Some of the CSR groups, they have shown. They have grown very well. But some of these CSR groups have not been growing at all. So separate groups are going very well. The moment you put a separate mission, then they take it forward and they do it very well, you know.
Okay. Yes. And a few observations. One is with respect to fertilizer industry. You know that the entire industry is driven by the subsidy mechanism from the government, of course, which is also linked to a lot of efficiency parameters these days.
Right.
But again, unless the cost of production of hydrogen comes down drastically, fertilizer industry may not touch it because the additional cost is not being reimbursed by the government as a part of the subsidy.
Absolutely. I agree. In fact, I am not even fertilizer producing of green ammonia, ammonium nitrate and things like that. I mean, it's fine. But fertilizer like urea producing from ammonia, I have a lot of question marks on that. First of all, you need a CO2 for producing urea. Okay.
But the other another theory, what they say for CO2 is they say that it can come from ethanol plants, with so much of bioethanol units coming up.
Yeah.
They say that that becomes a green CO2 and this is a green hydrogen, urea can be made. That is one school of thought, but how far it has progressed, I do not know.
No,
But
there are guys who are working on that. You're right, absolutely. It's also another. See, they're looking at. I mean, as you rightly pointed out, lots of the hitting from all sides. You can call it. No, nobody's leaving, but they don't know which one is going to be ultimately
yes,
the right thing that fits into that. But fertilizer, I tell you, I mean, most of you know that why they are talking about the nano fertilizer, nano urea, and all that. Either the fertilizer, nano urea, you know much better. You are in that industry. You were rather, and that is the one which actually that spreads quite well and then go to the right. Otherwise, the excess, the urea, what we put, I understand carbon dioxide evolves out of the ground.
yes.
So any carbon dioxide you absorb, 65% of the normal reformer carbon dioxide you absorb, 25% may go out of the thing. So, and that carbon dioxide evolves out of the ground after it is applied to the ground. It means the CO2 so-called CO2 you absorb from the reformer, and then you are actually melting out in various fields all over India. You know?
Correct.
I won't say there's something. Somebody used green urea. I said, please don't use the word green urea if you're producing from this route.
It's not.
Different route. Yeah. So,
But the only thing is, subject to cost economics, ammonia for DAP can be a green ammonia because there is no CO2 involved in the manufacturing of DAP,
ammonium nitrate, ammonium nitrate also is one.
Okay. Then for international transfer, you are mentioning about hydrocarbon thing, but even as ammonia, it can be transferred, no, for the international transport.
Yes. Ammonia can be transferred. Absolutely no problem.
Yeah.
No, I mentioned to you the same ammonia being transported from a green ammonia.
Yeah.
I think even Saudi Arabia is planning for a green ammonia transport to Japan.
Yes.
And they are going to burn the green ammonia at 10 to 15% in their boilers.
Correct. And one concern is for city gas distribution, hydrogen may be, in my opinion, too early because of the safety factors involved in hydrogen.
That's the last thing in the chain, in the value chain that will happen last, if at all. I mean,
because with the LPG, natural gas, and all those things, definitely. I mean, any non-technical person, even if the smell and all that, it's fine. And the risk with the hydrogen is when it catches fire, you don't even see the flame if it is daytime.
Yes.
Absolutely. So city gas distribution, as you rightly say, it should be the last in the priority, and it should not be even considered at the moment. Then one thing I wanted to ask you, for material of construction for hydrogen storage, transport, and all that, is not that carbon imprint becomes a problem, and you have to go for a very high grade steel and all that?
It's also there. The hydrogenation and all will take place, and you have the corrosion issues and the cracking issues. So obviously the material, but well-known theory that part is well known. So there's not a big. They are even talking about the composite lining normal steel vessels. I mean, carbon steel vessels. composite material lying inside to use of hydrogen storage is what being practiced. So the cost-effective solution, as what you said rightly now. I think a lot of, see, the solution to all these are new area. Why I said India can be easily in the forefront like other group is that you have the same place as, I mean, your same equitable position as others in the world in terms of certain developmental things. Yeah.
And one more observation is hydrogen itself is a greenhouse gas.
But then once you're burning it, it's water vapor that comes out.
No, I'm not talking about burning. When we store, I mean, handling, storage, and transportation.
Any leakage, any
Yeah,
small
exactly.
leakage and all that. That will be minuscule, but I think one has to live with that.
Correct.
He's considering that part right now. Yeah.
So anyway, I have nothing more to say. Thank you.
Okay, thank you. Nice talking.
Sir, there's one question in the chat box.
Yeah,
From
good
one of
Okay, I have to
from
open
one of
that.
budding engineers.
Let me just see that.
What are the skills needed to be developed by chemical engineers
Oh, a lot
in
of
order
things.
to compete in the new sectors who work predominantly in the oil and gas industry?
Should I just go through from top, bottom, top? How do you go this question? A lot of them are there, or
Sure, sir. Sure, sir. You can go through one by one, sir.
and,
Vishu, you can go, Vishu.
Hello, can I ask a question, sir?
Yeah, please go on.
I'll come back to this. Your point. Yeah, please.
Okay, we are now working with the Vice Chancellor of Anna University for
Okay.
direct thermal energy storage. See, the most of the energy required in the building or thing is for HVAC application. Is the fastest growing. Like any building takes about 60% of the energy is to HVAC.
Okay.
So we have now created a 1000 TRH trial plant at Capital Land. And we find that energy storage, direct thermal energy storage, is 1/5 the cost of battery storage.
Okay.
So,
to that, you said there's
sir,
direct thermal energy storage. By what means you said?
that is, we use chillers, operating chillers with solar power, and directly storing chilled water for use. And Tamil Nadu government has now come up with district cooling. That is entire places you can store you can run it in the night and store chilled energy and use it for air conditioning application during daytime.
Okay.
It can. So the cost, what was fascinating is the cost. The cost of thermal energy storage is 1/5 of battery storage.
Okay.
So I mean, now it's just a strange coincidence that we put up this 1000 TRH. It's a very minuscule plant as a trial basis at IT Park. And Tamil Nadu government, incidentally, has last week has come in the papers that they are thinking of district cooling. That is, you have a centralized, chilling plant, and you store energy. Whenever surplus energy is there, you store as thermal. The same thing can be the reverse of hot energy can be stored in place like Leh and all that for heating the barracks. L&T Madras, Chennai also was involved in a project where they are building for the barracks for Indo-Tibetan border for police.
Okay.
There are a lot of verdant land, so using parabolic solar, absorb and directly store the thermal energy.
Yeah, these can be used, I think, for some very specific applications and specific areas. Yes. Not an universal transportation basis and so on and so forth.
No, not very.
Secondly, the similar one which is also coming in vogue is actually the compressed air storage.
Yes.
Compressed air storage is what in USA.
Yeah.
They are talking a lot on that. And then one exactly the same kind of application. Yeah. It's a big way. I mean, people are talking, and there's somebody in India also now looking into that, talking to the IOC, ONGC, and all that. So similar to your thermal energy, the compressed energy.
Yeah. So what was inspiring your talk, sir, was even L&T starts in a small way. So we have also started in a very small way. 1000 TRH is minuscule.
Very good.
But
very good.
So how do you approach this L&T Green Energy Council, sir? Gopi, I'm lost.
Yeah, L&T, see, this particular one, the Green Energy Council is restricted to the L&T. Their kind of a strategy and all. They're all one European, one American, one US, and so on and so forth, So what I would, I mean, that's not right now is there, but If you want anything specifically required to meet the people in L&T, please let me know. Then I will sort of
Okay.
facilitate that process. Okay, you can call me up or send me a separate email.
Email. I'd like to.
Gopi will have my email address and you can.
Thank
take
you, sir. Thank you very much.
anything you want on that part, any specific questions
Yeah.
you say, I'll talk to the head of
Sure.
that green energy business.
Yeah.
Derek Shah is the one in charge of that. And we'll see if so whatever is possible, definitely we will.
I will send an email, sir.
Yeah, sure. I will do that.
Thank you, sir.
Sir, good afternoon. I am Panir Selvam.
Yes, Mr. Pandit.
The session was very informative and thank you for your excellent presentation.
Okay, thank you. Thank you.
As you indicated, this renewable energy capacity, our target is 500 gigawatt by 2030.
Yes.
And the asking rate is about 45 gigawatt per year to achieve that.
Yes, sir.
What I presume is this real challenge in meeting this kind of target is now our country don't have the production capacity of the polysilicon and wafer.
Exactly.
How to overcome this one? Because the entire thing is being imported now. 95% of the polysilicon capacity is with China.
Yeah, absolutely. You're bang on that. That's why I put that as a big challenge. And a group like Reliance have got a plan to put a polysilicon plant. I have not heard anyone else in India right now talking about it, because that itself is a capital-intensive plant, polysilicon project. It's not that everybody can put up that plant and then wait for. So my take on this is actually right now it is people have done the supply chain of the big groups. For example, Renew Power or Adani's and the solar guys. They are quite well connected. When you talk to them, they are adding on the modules as of now. But I think 500 thing with just coming from solar alone would go to be difficult. Something like wind also has to enhance. Something like offshore wind has to come in. Offshore wind is nobody is bothered about talking about it, but it will come out in the next 2 years. It will pick up like anything. In Europe, they are using it extensively. So this is a challenge. I mean, I have no answer for that right now. I mean, this what you said, polysilicon.
Apart from the financial challenge, capital cost and all, whether do you have the technical feasibility?
So which one for polysilicon?
Polysilicon, yeah.
No, polysilicon, their technology and they're available. That you can get. I mean, import technology and then put up a plant. That is not a big deal. It's a well-known process. Only problem I mentioned to you that capital intensive and nobody thought earlier for our requirements we have been importing, so that people are quite happy with that limited supply within India. So, but now today it's a big challenge. We need to have some plants. But I don't see Reliance has got in the way we can have a word with Dr. Partha. Reliance don't have that on their top priority at this stage. But then for them also, on the solar generation, one has to see that they are only making panels, but where they're getting the material from. But I think the people are tied up quite well with Belgium and few companies, what I've heard. Especially these Adani's and Greenco and the people who are already in the business. Who are already there in the last 5-10 years in the business. No? They are quite well, they have got a good supply pipeline.
Thank you.
I just see the chat box, some questions, Gopi. Yeah, of course, carbon footprints will add cost, transportation cost, which I mentioned anyway. Definitely, they're going to add for the hydrogen. Obviously, the cost of hydrogen has to come down for reducing the transportation cost. I mentioned that. In fact, I gave you the transportation chart also.
Yes, sir.
Water will be the biggest challenge. We talked about it. Yeah, my friend Lalit is there. I'm happy to see Lalit on the group. Water will be the biggest challenge in these times when the.
Good afternoon,
You're
sir.
still there?
Yes, I'm very much
Sir,
there.
Hi, nice seeing your question. Yes, I think water we talked about a lot, Lalit. I think it's mainly that's one of the reasons why I mentioned to you about this brackish water, if we can do the earliest. And my friend is a very modest man doing in US, but I was encouraging him. That's going to be a big changer, and also reuse of the water. I mean, that's something which water scarcity would be one of the major things. In fact, normal drinking water scarcity in about 50 years from now, 25 years from now, is going to be a big question mark. So, like Middle East, maybe you have to go for the desalination plants. Chennai had got actually long back in jail at that time, two very big, if I remember, the water desalination plants, I mean, seawater desalination. So, okay, Ravi Kumar, let's see. Then quickly, any other, what are the skills needed to be developed by chemical engineers in order to complete this new sector? See, what I would say, actually, is a good question. Electrochemistry is the one subject which we all have gone through very well. Chemical engineers are never heard, read even in IITs, hardly that is being dealt with. But now, what I understand, even my friend who is a professor emeritus in chemical engineering from Boston area, he mentioned to me that they are introducing a curriculum. They have actually in US, they have a curriculum where this is a the electrochemistry, batteries, and all is a subject in chemical engineering. But now I think in even Indian curriculum they are introducing that, and obviously that is one area I would say they should be well aware of that. Secondly, the the complete energy integration systems people have to learn. Energy process improvements, I think they have to learn. They're separate subjects they should go through. Otherwise, they have to even sort of self-reading on these areas would be very essential for chemical engineers. And not just by looking at one particular specific issue of only solar, only wind, and how to manufacture. That is what as the industry we looked at it. But as a chemical engineer, should look at the whole processing part of it, complete value chain involved in these various new technologies. They are not really new technology. They are all there existing, but they are coming into the limelight now, I would say. And more in detail, we can talk to the persons who are specifically involved in that area.
I will just like to add with respect to
please.
the electrochemical technology.
Yeah.
Anna University's chemical engineering syllabus does have this as a kind of elective with a very elaborate coverage of the subjects.
Good. I meant actually apart from the theoretical part of anode, cathodes, how the electricity, how the which flows where and all that, you have multiple kind of a usage of this electrolyzer as can work like a battery, or it can work like as a fuel cell, what we say, or it can also act like a hydrogen generation. And it can also, there are systems where you can also avoid carbon abatement in the electrolyzer, remove the carbon dioxide in the electrolyzer directly. There are so many developments are going on around electrolyzer. Those things to be incorporated in the subject. Otherwise, just by reading the electrochemistry by itself, like the chemistry, BSc chemistry people read a lot electrochemistry. I think chemical engineers, I think they need a little more than that application part and also the second stage. I would say, from the science to the technologies part, what I meant actually. Yeah, thank you. I think one of you have said that. Thank you. Green energy, both on a global scale. Water. I think everybody has got a water. I think we need to talk on this water. How to get this wastewater? These.
Anytime, sir. In fact, we are having 2 conferences lined up, and I'm chairing those. Okay. I will send you details of those.
Okay, sure. You can send it to this group also.
I will do that.
I think there, Mr. Gopi is the organizer of whole thing, so you can send it to him. Okay.
Yes, I will do that.
That will be nice for them also. For interested group in this area, they can also participate. Mr. Lalit is one of the innovators in the water technologies from Diva Envitech. So he's been very. As I seen him in my other group, PPMI, I told you, Process Plant Manufacturing Association is there. And I think with very innovative solutions, he comes in and he participates in a lot of seminars outside India, in Dubai and various places. So he can share a lot on the water. Maybe one day you should give on the water some talk to Gopi's
Definitely, sir. Definitely.
Yes,
we are
yes,
having a session on sustainability with a focus on water end of this month on 30th. And then 19th and 20th of January, we have EnviroVision, where I'm again the chairman. Okay. So I will send all the details to Mr. Gopi.
Yeah, you can just mark it to me also. That we'll.
I will do that. I will do that.
And then he will definitely call you one of these Sundays to have this similar kind of a.
It will be my pleasure. It will be my pleasure.
There are about 100 people join normally in this group. It's a very large participants of people who are all doing so. They will love it. Okay. Okay, if I am misreading any of the questions, you can ask me if you are still there. Water can, I think people, lot of questions around water thing is coming. Otherwise, all thanks only, otherwise won't consumption. Lanco had planned, okay, making policy. Okay. Yeah, Lalit, once again, your comment I've read about the Lanco plant making polysilicon plant, but they have shelved due to China price and investment became unviable. I think a lot of it is coming from China, right, Lalit, on this polysilicon?
Yes. Mostly from polysilicon is coming from China. Most of the European companies have reduced their manufacturing also because of the unviability. You know, the price of polysilicon from China is very low, and they are really believing in bulk.
And then they are able to supply, suppose, to our even the future.
Yes,
So you
even
think
though
that
sometimes the quality is a compromise, you don't get that 7 degrees of nines, 99.9999% purity.
okay,
But I think Indians are very comfortable with low pricing.
okay,
We
right.
don't really bother about energy efficiencies, and sometimes,
Yeah.
though the culture change is coming, attitude change is coming now.
Yeah, the efficiency drop what you're saying in that board, and then they are ready to live with that. But Reliance is
Yes.
not ready to live with that, so they are putting up their own polysilicon plant, probably.
Absolutely.
Ultimately, they will put not in the chain of even maybe 2-3 years down the line.
Yes.
Yeah, I think somebody said, how can a green hydrogen sustain operation when renew power is not available 24 hours, particularly for refinery? And so I mentioned to you the same thing. That's a battery system storage is very essential. So you can't just depend on only the 10 hours of solar power. So you have to have 2 times that. So obviously more solar panels for the whole 24 hours energy, and the balance 1/3 you consume in 8 hours and other 2/3 have a battery storage. So all the other components are becoming equally important and not just concentrate only on one final thing like green hydrogen. Good. I think we had a long session, exactly 2 hours since we started. So I think Gopi, your timing is absolutely perfect. What you said, 2 hours it takes.
Else has a question, you may please unmute and ask one last question before we let Mr. Ravindranath go.
Good. I think that's it. Some people have also
Yes, sir. Yes, sir.
long session and also Sunday, so they have other things to. In the
Yes,
match
sir.
starting at 2 o'clock.
So one last question, if possible.
Yeah, please.
Yeah. Please go on.
So,
Yeah, please go on.
so what are your thoughts on biorefineries? There is a lot of biomass-related processes evolving to directly produce hydrogen and methane compositions. Any thoughts on that?
Actually, my colleague Balram was mentioning to me about this. I have not given much thought to that because it's not really caught up in a big way. But I think it is even whatever you do in the biorefinery, the quantity and then first of all the collection of the right kind of biomass, and then also you are taking from the waste, is it? Or from the
Yeah,
raw
so
material?
there are basically the raw material. Basically, it could be the various agricultural waste aspects as well as municipal or some things which are particularly grown for this purpose. The technology claim is very high conversion rates and very low cost of producing hydrogen and also
But
methane in this
thermal conversions, no, that is mainly
thermal conversion. That's right, sir. Yeah.
thermal side, so which is again high temperature related thing. And what they found is the same thing with these bioenzymes and then converting into the bioethanol, which is also again acceptable route. So biomass and then cellulose material, what I have shown this thing, both SAF as well as the ethanol, sorry, 2G or kind of a thing. And 3G, 2G, 3G is what I think people are preferring rather than getting into that. I believe one more thing I understand was again capital intensive and also energy intensive. It also consumes a lot of energy. Again, we are losing our focus on that. I do not have much details on that biorefinery.
Thank you, sir. Thanks for that.
Okay.
Yes, sir. Thank you very much for taking your time out on a Sunday morning to be with us, sir.
No, thank
We
you.
appreciate your time.
Met a lot of friends here on the group and my own friends Gautam and Aravind and Lalit and all these guys, and also
In fact, Mukesh could not join today.
Who?
Mukesh is traveling out with his family in Delhi.
Who?
Mukesh.
Mukesh Kagram.
Mukesh Kagram.
Kagram.
Yeah,
Okay.
yeah, Mukesh Kagram. Yeah.
Yeah, I would have loved to
Yeah,
have
so
seen him
he's in
also.
Delhi.
Okay.
Right, sir. Thank you very much. Take care,
Thank
sir.
you.
We'll stay in
Thank
touch, sir.
Bye.
Thank you very much.
Thank you all guys, and for
Bye.
your attention and then all the questions. Thank you.